everyone, this is the Simplifying Expressions with Rational Numbers guide and notes. We're going to start by defining some vocabulary terms. Now these should be a review, but if not, you can learn them now. The first term is constants. Constants is a fixed value. It's any value that does not change. For example, -6, 0, 76 hundredths, a half, just any value that's sitting there that will not change. The next term, variables, is a quantity that may vary. It's often represented by letters in expressions. It could be A, B, C, X, Y are common variables you may see, but really any letter that represents a quantity that can vary is a variable. Terms are a constant or a variable or a combination of constants and variables that are separated by plus and minus signs in expressions. For example, you could have 2x, which would be a combination of a number and a variable, or you could have 5 or y. All of these are examples of terms. Expression is a combination of terms with the operation symbols. For example, 2x plus 3. So here we have a term here and a term here, and an expression is just the combination of terms. Commutative property is the property that says numbers can be added or multiplied in any order. For example, 2 minus 5 is the same as -5 plus 2, and 2 times a -5 is the same as -5 times 2. Associative property is the property that says numbers can be grouped differently to add or multiply them. For example, if I have 3 plus 6 plus 4, I can add 3 plus 6 together and then 4, or I can group 6 plus 4 together, then add 3. That is the associative property. The distributive property states that A times the quantity B plus C is the same as A times B plus A times C. In an example, this looks like 3 times the quantity x plus 4 is the same as 3 times x plus 3 times 4, which is 12. Simplify the following expressions. Two strategies that I like to use are to color code the like terms. For example, right here we have x plus x. And I also like to note the symbol in front of the term. So for example, here it's a plus and here it's a plus. And make sure I'm circling that operational symbol with the term so that I don't get confused if it's a positive or negative. Now let's combine like terms. X plus x is 2x, and then I have a plus 3. Next question. I have x plus 3x, and then this y is a different term because it's a different variable, and then I have my constant of -5. So combining like terms, I have x plus 3x, which is 4x. I have my plus y, and then I have my -5. Going on to the next question. Let's mark 2a, and then this minus a, so like a -a. And then I have my two constants here of plus 8 and -5. Combining like terms, 2a minus a is a. Plus 8 minus 5 is going to give me plus 3. Next question, I'm going to use the distributive property to get rid of these parentheses. So it's going to be 2 times a, which is 2a, and then I will go 2 times 3, which is a positive 6. Looking at this next expression right here, first thing I'm going to is get rid of my parentheses with the order of operations. So I have 3m, 3 times m, which is 3m, and then I have 3 times a -4. Notice that minus right there. So that's going to be -12. So I have m plus 3m minus 12. And then I'm going to look at my common terms here. So I have m, 3m, and then I have this -12. So combining those together, m plus 3m is 4m, and then I have my -12. I know an expression is completely simplified when there are no more parentheses and all like terms are combined. The commutative property is useful to use when changing the order makes the expression easier to work with. So sometimes when we combine compatible numbers, then the mental math may become easier. So the commutative property would be useful in those situations. The associative property is useful to use when grouping certain terms makes the expression easier to work with. So similar idea. Sometimes if I group certain terms together, the mental math will become easier. So that's when I would use the associative property. So the commutative property is for changing the order. The associative property is how we group the items. The distributive property is useful to use when an expression is multiplied by another term. That's how you're usually going to see it for now. In the future, you will see expressions being multiplied by expressions, and you will also use the distributive property in those cases. All right, let's look at these expressions here. Negative 5x plus 6 plus negative 7x minus 8. So I have highlighted my like terms here. I'm going to need to change the order right there, bring those ones together, change them together, and then group them together. And that's going to be the commutative property because I changed the order, and then the associative property because I'm grouping them together. And then I'm going to combine plus 6 and minus 8. So negative 5x plus a negative 7x is a negative 12. 6 minus 8 is a minus 2. Next question, let's highlight the like terms, which is negative 6/10 x and then plus 5.4x. And I will highlight this one right here in a different color along with the sign in front of it. So I know that it's a minus. It's different because it has a y there at the end. Now these ones are already in the right order, but I am going to group these together right here. So when I group the things together, that's going to be associative property. And then let's combine them. So I have negative 6/10 plus 5.4, and that's going to be 4.8 x. And then I still have my negative 6.3 y. All right, let's look at this one. I have an term being multiplied by an expression. So I know I'm going to need to be using the distributive property to simplify that first for my parentheses. So I have negative 2 times 1.5x, which is negative 3x. And then I have a negative 2. Notice that's a negative 3. So negative 2 times a negative 3 is going to be plus 6. And then I have my plus 4.5x here at the end. Now let's change the order so I can look at the like terms. I have this one right here, and I have this one right here. So changing the order is going to be the commutative property. And then when I combine them together, that's going to be the associative property. Now if I do negative 3x plus 4.5x, that's going to give me 1.5x, and then I have my plus 6. Next question, for an 8/10 a minus 2 and 1/10 a, so those are the same terms. So those are like terms because they both have an a, and then let's highlight these terms right here, negative 6.3b and a positive 7b. Again, notice that I'm hiding the plus or minus in front of the term so I don't get confused there. So now we are going to regroup these. I need to group these two together. So now we are going to change the order, which is the commutative property. And then I need to join the like terms together, which is the associative property. 4 and 8/10 minus 2 and 1/10 is 2.7a. And then negative 6 and 3/10 plus 7/10 is plus 0.7b. I look at my next question, I immediately notice I'm going to have to use the distributive property right here to get rid of these expressions. So let's rewrite it. So I'm negative 6 plus 1/2 x, and then 1/2 times a negative 10 is a negative 5. Let's looking at my like terms. I have my term right here in the middle, which is all by itself, and then I have my negative 6 and my negative 5. Really quickly, I use the distributive property, and I also am going to use the commutative property. I'm going to change the order to combine the like terms. So I have 1/2 x all by itself, And then I have negative 6 minus 5 is going to give me negative 11. Next question, again, I'm going to be using the distributive property to get rid of these parentheses. 4 times 2x is 8x. 4 minus 3 is 12. And then I have plus 6.75. So I use the distributive property. Let's highlight the like terms here. I have my 8x all by itself. I have my negative 12 and positive 6.75, which are two constants, which I will add together. So that's going to be the associative property. This will simplify to 8x, and then I have negative 12 plus 6.75, which is a negative 5.25. Okay, last question. I noticed that again, I'm going to be using the distributive property. So I have 3/4 times 8x, which is 6x. 3/4 times a negative 4, and that's going to give me negative 3. Then I have a minus 1/2 x. So let's reorder these. So I have my 6x and my negative 1/2 x. So we've used the distributive property, and we're also going to be using the commutative property, and we'll also be using the associative property when we combine them together. Then we have my negative 3 here. So we have negative 6x minus 1/2 x is 5.5 x. Then we have my minus 3. This is a great question here at the bottom. It says, how can you check if you correctly simplified the expression? So if the expression is simplified correctly, these should equal each other, meaning if I plug in a value for x over here and I get an answer and I plug in the same value over here and I get the same answer once it's all simplified, then I simplified the expressions correctly. A great value to enter would just be 1. That's simple to enter in. And if I plug in 1 and simplify for both expressions and it gives me the same answer, then I simplified it correctly. Equivalent expressions. Circle the following expressions that are equivalent to negative 3x plus 6. I'm going to go through and highlight terms here just so when I go through and simplify it, it's going to be a little bit easier. I'm going to highlight this plus 2 so I can notice that's plus 2. That's minus 2. I'm going to highlight my constants over here, highlight my constants over here. So I'm going to go through and highlight my x value. So I have one there, one here, x, negative 4x minus x, negative x, and then that one right there. Okay, let's go through and simplify. Looks like on a lot of these I'll be using the distributive property. So I have negative 3 times x is a negative 3x. Then I have a negative 3 times a positive 2 is a negative 6. Next question, I have a negative 3x right here. And then I have a negative 3 times a negative 2, that's plus 6. Next question, I have a negative 4x minus x, which is a negative 5x. Then I have my plus 6. Next question, I've got to do my distributive property here first. Let's write down the negative x, and then I have negative 2 times x is a negative 2x. And notice this is a negative 2 times a negative 3. Watch out for that sign right there. That's going to give me plus 6. So this is going to simplify to negative 3x plus 6. All right, so then it goes and asks me which ones are equivalent to negative 3x plus 6. So let's circle the ones that simplify to negative 3x plus 6. So that's 3x minus 6, negative 3x plus 6. And right here, this first, so the second and fourth one. How do you know which expressions are equivalent? Well, I simplified them, and they simplified to the expression negative 3x plus 6. All right, we're going to do some error analysis. We have work done for us over here that is incorrect. So we've got to go through their work and figure out what errors were made. So the first expression says 4a minus 2 times a plus 6. So if I'm going to simplify that, I got 4a right here. And then they use the distributive property to figure out this next section. So negative 2 times a, negative 2a, well that's right. And then it should be negative 2 times 6. That should be a negative 12. And they have a plus 12. So there's my error right there, is that they did not distribute that negative 2. They just distributed positive 2. And that's easy to miss, especially when there's this other term here at the front. So make sure you're noticing this sign of the term that is being distributed. Okay, let's look at the next one. We have 4a which is what they have, and then we have the distributive property again, which is negative 2a, which is correct, and then they should have negative 2 times 6, which is a negative 12, and they have a plus 6. So in the previous example, they didn't distribute the negative, but this time they didn't even distribute the 2 at all to the 6. They only distributed it to the a. So they did 2 times a and just completely forgot about 2 times 6. Next question. Again, we have 4a. Try this again with the distributive property. Negative 2a, well, that's correct. Negative 2a, negative 2 times 6, which is negative 12. Awesome. Let's keep going. We have 4a minus 2a. So 4a minus 2a is a positive 2a, and they have a negative 2a. So they combine those terms incorrectly. Okay, to real-world application of expressions. Antonio wants to buy a shirt that costs C dollars. The tax on the shirt is 5%. To determine the total cost of the shirt, you could write the expression as, and then we need to write it down. So if I need to figure out the total cost, that's going to be the cost of the shirt, which is C, and then we need to add that to the tax. The tax of the shirt is going to be 5%, which I'm going to write as 0.05 because I'm writing it in an expression. So doing fraction or decimals is preferred. So 5% of the shirt. Don't just leave it like this. It's 5% of, remember of means multiply, of the cost of the shirt. So C plus 5/100 times C. This expression shows the total cost of the shirt plus 5% of the shirt price. Another way you could write the total cost of the shirt is, so now let's combine like terms. These are both similar terms or like terms, so we can combine them together. Now it doesn't say 1C, but I know it is 1C. We don't usually write the 1 right here. When there's just a variable there, it's 1. So 1C plus 500C is going to give me 1/500C. This expression shows the total cost is 105% of the shirt price. And that's right, because if I were to change that to a percent, that's going to give me 105% of the shirt price. Anna wants to buy a book that costs D dollars. The bookstore is having a sale today, and all books are 15% off their original cost. To determine the sale price of the book, Anna could determine D minus 1/1500 D. Explain what this expression means in context. All right, so it tells us that D right here is the cost of the book. So if I have the cost of the book, then I am minusing 15% off of the cost of the book. Remember, it's 1/1500 times D times the cost, because of means the multiply. You're figuring out 15% of the cost of the book. So to get the discount price, we're getting the cost of the book minus 15% of the cost of the book. Anna could instead calculate 8/500 D. Explain what this expression means in context. So if we look at this, it's saying instead I could calculate 85% of the book, of the cost. That's what this number right here means, 8/500 of the book. Why is that the same as this right here? The cost minus 15%. So if the cost is 100% and I am taking away 15%, that's going to give me 85%. So what she pays is 85% of the book cost. Frank wants to hang a rod that is F feet long horizontally on an 11.5 foot wide wall. He wants to hang the rod in the center of the wall. Write an expression to determine how far the end of the rod would be from the wall's edge. All right, so there's probably a couple different ways we can do this. Let's start with a picture. If I have a wall and I want my bar or my rod to go here in the middle, right? I know that the wall is 11.5 feet long. I don't know how long the rod is, but it does tell us that it is F feet long. So that's my variable F. So how can I figure it out so it's exactly in the middle of the wall? One way I could do that is to figure out 11.5 divided by 2 because that's going to give me the middle of the wall. So if I take 11.5, and I'm going to write that as a decimal, 11.5 divided by 2, that's going to give me the middle of the wall. So to figure out the distance from the end of the rod to the wall, I need to know this distance, which is 11.5 divided by 2, because I know how long the wall is, and I need to figure out this distance. So this minus this will give me this purple section. So this distance right here is going to be f divided by 2. Whatever that f is, it's going to be f divided by 2. If the rod is 3 feet long, use your expression to determine how far the end of the rod is from the end of the wall. So now we can do some substituting. We have 11.5 divided by 2 and minus f, which is now 3 divided by 2. And to simplify that, and I get 4.25 feet. Lara received a 25% increase in her salary S. Write an expression that represents her new salary. Well, I can do this one of two ways, similar to our question on the previous page. If her current salary is S, and then she receives 25%, written as 2,500 of that salary. So S plus 2,500 S, or I could write that as 1 and 2,500 S. By what fraction did her salary increase? Her salary increased by 1/4. So that's asking to change the percent into the fraction. If her new salary is $62,500, what was her salary before her raise? So I know that 125S is going to equal 62,500. That's her new salary, 62,500. So to figure out what her salary was before, I'm going to divide by 1 and 2,500 each side, and S will equal 50,000. Tom bought 2 large pizzas P and 3 bottles of soda that cost $1.50 each. There is also a 7% tax on the food. Write an expression to represent the total cost of the pizza and soda plus tax. All right, so the 2 large pizzas is P. So we have 2 times the cost of the pizzas, which is P, plus 3 bottles of soda that cost $1.50 each. So 3 times $1.50. And then I also need to add a 7% tax on the food. Let's simplify this first. So 3 times $1.50 is going to give me $4.50. So just the cost of the food is going to be 2P plus $4.50. Now to do 7% tax on that, we need to add 7%, which I'm going to write as 700 times that cost of the food. 2P plus $4.50. So it's this right here. 2P plus $4.50 plus 700 times 2P plus $4.50. So one pizza costs 3.5 times as much as a bottle of soda. So P equals 3.5, which I'm going to write as 3 5/10 times $1.50. And that gives me $5.25. So that is the cost of a pizza. So now let's substitute 5.25 in for P. We get 2 times the cost of the pizza. I'm going to use parentheses so I don't get confused there. Plus 4.5 for the 3 bottles of soda. Now we're going to do the tax, which is 700 times the 2 pizzas. Plus the bottle of soda. Simplifying this, I get 1050 plus 450 plus 700 times 1050 plus 450. Simplifying all of that gives me $16.05. Okay, everybody, that's it for today. Thank you.